The negative pressure isolator in the aseptic training suite is different to a typical pharma isolator, laminar airflow hood or biosafety cabinet, all of which operate using positive air pressure. The isolator you will use operates at a pressure of -100 to reduce contamination. If the isolator is open, please close it carefully and ensure all handles are turned fully to the left to maintain a seal. After turning on the isolator at the main plug, use the overhead panel to turn the isolator light on. If you should accidentally trigger the alarm, press the alarm button to turn it off again. Gloves will appear inflated when the isolator is switched on. Check that the isolator is at the correct pressure before use. If the reading remains below -100, there may be a leak in one of the glove port gloves. Visually inspect the gloves for any cuts or bulges. Leaks can also be detected using a glove leak tester or GLT. First, turn on the GLT and place it over the mouth of each glove port. A reading close to 0 confirms that glove port is sealed correctly, but larger readings indicate there may be a leak in the glove, in which case the gloves will have to be replaced. Materials to be brought into the isolator are placed on the isolator shelf. All materials, including the IPA bottle, must be sprayed down at the isolator shelf using another bottle of IPA. Most of the time there is no issue with spraying, but sometimes the manufacturer might advise not to spray too forcefully in case the ink on a label gets smudged, as this could remove the expiry date, for example, or if any part of the packaging is made of paper, it might get too wet and tear. Place all items into the pass-through hatch as efficiently as possible to reduce the risk of contamination from the outside. Spray the glove ports and the gloves you are wearing with IPA before putting your hands into the glove ports. If you don't, you may find the isolator gloves very challenging to fit on. When replacing isolator gloves, you can see here that they are held in place by these really sturdy red O-rings. Please take your time to fit the gloves correctly, otherwise you may struggle to place the O-rings securely around the cuffs. Or you might stretch the gloves too much, causing bulges or tears that lead to air leaks and contamination, and you would have to repeat the whole process all over again, wasting time and money in the case of a contamination. Although you're not expecting any at this stage, give the gloves and fingers a final check for any visible leaks. Then check the pressure again, and if it's at -100, that confirms there are no leaks. Press the foot pedal to open the inner door of the hatch. Slowly bring each item into the isolator. Movements in the isolator should be kept slow and deliberate. Fast movements will interrupt the laminar flow of air, and by laminar I mean the unidirectional flow of air from the overhead HEPA filter. Do not place items on top of each other. The downward flow of air cannot hit what is underneath. Separate items out so they are all exposed to the first air. Gloves come marked as left and right. They can be opened up if you expect to use them, or left in the packet and placed out of the way of your working area until required. The next items to be sprayed in are agar plates, and there are two types: Sabrodextrose agarose and Triptych soy agarose. They're for growing different types of microbes such as fungi, molds and yeasts, and for microorganisms like bacteria. There is a risk for both in the isolator, so we really need to protect patients from microbial contamination. And we do that by placing these agar plates, which we refer to as settle plates, in the isolator. The set of plates come triple bagged and gamma irradiated, and the outer bags were removed and sprayed down in the materials airlock hallway prior to entering the clean room, as you saw in the previous video. The red dot label confirms that the plates are sterile. If you don't see the red label, that means that the plates may be non-sterile, with something invisible to the naked eye already growing on them. This could lead to a potential false positive when the plates come back from the microlab, so always check the labelling. Bring all your material in one go, and again separate everything out as best you can and keep your work area as clear as possible. The one item that should probably be included here but is missing is a small disposable bin. But the isolator is simply too small, and we don't want to increase the risk of contamination by cluttering up the isolator. For that reason, unnecessary items are also removed immediately, such as the tray. Throughout this process, you can see that the operator's movements are very slow and deliberate, so he's minimising the risk of contamination through particle generation. You might think the operator should wait until he has several items to remove together in one go, but that would require more time and the inner door would remain open for longer. That would expose the inner chamber of the isolator to the pass-through hatch, which is a high risk for contamination. And you can see the glucose bag is poorly positioned. Open the agar plate slowly. You don't want to generate a large amount of particles or movement, which could accelerate particles. And lay them in different areas of the isolator to make sure they're reflective of the whole isolator environment. The operator here is following a recipe, so you can see he takes saline, which is also double bagged, and opens it with deliberate slowness. Before attaching it to one of the hooks. And the outer bag is immediately removed from the isolator. The next step is to take 1 ml from the active ingredient, in this case the antibiotic. Normal procedure is to check the label first to ensure it is the right active ingredient, check the lot number and the expiry date are as expected. Get a second person check to verify all details, and in the meantime prepare a 2 ml syringe. Open the syringe partially at the handle end and leave it towards the back of the isolator where the direct airflow is strongest. Partially open the corresponding syringe needle at the base end. And quickly twist it into the syringe to minimise exposure. Unsheath the needle while holding the needle away from you. If you hold the needle downwards, you may get a needle stick injury or pierce your glove. Pull the handle of the syringe down by about 1 ml to overpressurise the vial. Pierce the rubber lid of the antibiotic with the needle and make sure your needle always remains in the liquid while drawing. You will see that the liquid just flows into the vial without any force. After a while, you will have to apply a little force to draw it out. To press the syringe lever to remove the air and to adjust the volume in the vial to 1 ml. When removing the needle from the bottle, tilt the bottle so that the needle is in air rather than liquid. The operator here is flicking the side of the vial to remove any last air bubbles as much as possible, and he moves the base of the vial to the 1 ml mark. Once you get your second person check to confirm this, you can proceed to the next step. Resheath the needle briefly to prevent any ingress. The glucose bag has 2 stoppers. The white stopper is labelled in and the blue stopper out. Remove the white stopper and inject the vial contents into the glucose bag. Resheath and remove the needle and add it to the sharp spin. You might also be able to add the syringe like here, depending on the particular policy of where you work and how toxic the product is. Make sure to fully close the lid of the sharp spin. Now your product is ready to go and you can take everything back out of the isolator that will not be used for any subsequent operations. If you're going to be using some of the materials again soon, the items you require can be left in the isolator, which should remain switched on. Regardless, clean down the workspace in the isolator and make sure all items are spread out evenly. And that concludes this brief demonstration of operating within an isolator. Thank you.